Okay, guys, tonight we're going to be looking at linear patterns in tables and some other forms and on graphs, and we're going to write some linear functions from those. Okay, in this one we see that familiar y equals mx plus b, the equation for, a linear equation. Over here though, it says linear functions. So we're going to be swapping out the y for the function of x. Let's take a look at the graph you're looking at there, and we're going to find out the intercept and the slope, and then we're going to write a linear function. And so here we go. We can see right here that the intercept is 0, 1. So b has to be 1. This is just like in class today. Let's take a look at the slope, and here we're just going to count out a slope, down 3 and over 1. And so that's going to look like negative 3 over 1x, and we've got y. Of course, we can simplify this to just negative 3. So our linear equation is y equals negative 3x plus 1. We're going to say, what's the linear function? And we know that y is the function of x. And so we substitute, and we have the function of x is negative 3x plus 1. Here we have a table, and we're going to first identify the y-intercept. The y-intercept is when x equals 0, so that's a no-brainer. The y-intercept is negative 1. Now let's find some slope. Here it's plus 1, the change in y is plus 1, and it's plus 1, and it's plus 1. You're going to see this consistent pattern every time. The change in y is plus 1. The change in x is plus 2, plus 2, plus 2. And so the change in x is plus 2, and we've got our slope. So let's write out a linear equation. Y equals 1/2 x minus 1, and now let's write a linear function. So here we have a table, and you'll notice there is no x value that equals 0 yet. But let's start with slope. It looks like the y's are changing by 800 each time, and the x's are changing by 2 each time. So our slope is the change in y over the change in x, and our slope appears to be 400. But what about the y-intercept? We don't have x is 0, but we can count back evenly here. 8 to 6, 6 to 4, 4 to 2, and lucky for us, 2 lands right on 0. Sorry about that. So let's count back here. 800, 800, 800, and 800. So if we graphed this, we would find that that line headed right at the origin, but we don't need to graph it. We can tell that the linear equation looks like this, plus 0, which we don't need to include. So our linear function looks like this. Now, there's a question in here about discrete or continuous. We didn't talk much about this in class. Here we have individual points, the point 2, 800, and 4, 1600, and so on. We're skipping from point to point, and that does make us think that this could be discrete. Discrete means point to point. Continuous gives us the idea of the line. But if you jogged hours, do you only jog for 2 hours or 4 hours or 6? No, you can jog for 2.5 hours or some other part of an hour. So this might make us think that this was in fact a continuous function. Remember, individual points tends to mean discrete, but a function like this is fluid or one long line. This would be continuous. Sometimes you have to look at the context of the problem to tell whether it's discrete or continuous. How many calories do you burn in 2.5 hours? Well, we know that x is the number of hours, so we're going to say the function of 2.5 is 400 times 2.5. And so that the function of 2.5 equals 1,000. And so you would burn 1,000 calories if you could run for 2.5 hours. That's physically impossible. I've tried it. Turns out it's not physically impossible to run for 2.5 hours and burn 1,000 calories. It's also not impossible for you guys to do these next 3 questions and then write an essential question. Use the graph or some tables and do the best you can to find 3 linear functions. Here are the 3 linear functions you should have found and some answers to those last 3 problems.
Make sure to do your essential question.
Oh, yeah. And as Mrs. Aki mentioned, make sure that you do your sorry about the mess there. Make sure that you do your essential question.